All right. Well, it looks like we have all of our panelists on. So I think we will go ahead and get started here today. And I'm going to give a little intro, and then we'll get started actually with the content here for today. So, um, number one, I just want to thank you all for joining us. It's been an interesting project. George Haynes and myself have been working on coordinating a three-part series here talking about some different issues surrounding electrical vehicle adoption in Montana, understanding some of the opportunities and some of the challenges that that might bring from kind of a whole variety of different angles. So George and myself both work for MSU Extension in the Department of Agricultural Economics and Economics, and neither of us are necessarily experts in this area, but we wanted to provide a platform here where we could bring some of those people that are experts in different areas that will be affected by electric vehicles to talk about that and to, have a discussion about those things. So after today's session, our second session will be on March 4th. And kind of the issues here is going to be talking about rural electric vehicle adoption, transportation funding. So we're going to have someone from the legislative division, the interim transportation committee, I think I put division there, is working on some issues related to this session. So they're going to bring some perspectives there on kind of some legislative angles at this. Maureen Bach, who's at the Oregon Department of Transportation, but has some pretty strong ties to Montana, is going to present on, they've had some studies in rural Oregon about some different ways of taxation and what supply side issues look like in there. So she can share some of the results of the work they've been doing in Oregon. And then the final speaker on March 4th will be David Kack, who's with the MSU Western Transportation Institute, and can kind of give an engineering perspective on a variety of issues there as well. So mark your calendars for that one if you'd like to join us for that. And then our final session in our three-part series will be on May 6th. And here we're going to talk a lot more about Montana's electrical grid. So we'll have someone from Northwest Energy, and I think I've got the right person, but I just not quite ready to confirm their name for our rural electric cooperatives. Is going to talk about some of their perspectives on what kind of challenges and opportunities they might see if we did have a greater number of electric vehicles in Montana. And then finally, we'll wrap that one up with Neil Ullman from the Montana Department of Environmental Quality. So those are kind of the two sessions beyond today. So mark your calendars for those, and hopefully we can have a nice discussion. Here's some different perspectives about different angles and how it would affect different people, different industries in Montana. So just a couple notes about the webinar system today. First of all, you can change your layout on the top right. So if you don't want to see talking heads, you can minimize that and see just the slides as well. We do have a chat window there, and I would encourage you to send in questions, and you can send them to everyone, or you can send them just to the hosts. And then when there's a natural pause with the speaker, I'll ask some of those or when they wrap up. And then I've also asked all three presenters today if they could hang around to the end, and then we can maybe take any questions we've got left as sort of a question to the panel, or maybe more than one of them will want to address a particular question. So next up, I want to introduce our first speaker today, Nick Shrauger. Nick is a retired associate professor of electrical engineering here at MSU, also happens to be an EV owner, and he's going to give us a little bit of a broad picture and also some consumer perspectives on electrical vehicles. So Nick, if you're ready, go ahead and take it away.
Okay, Joel, thank you very much. I want to start by saying I grew up in Deer Lodge, which was then a major division point for electrified Milwaukee Railroad. During high school, I had a part-time job servicing Milwaukee passenger trains. I remember how trains quietly swooshed into the station powered by electric locomotives. Swoosh, now isn't that a nice scientific word? As passengers got on and off, we removed garbage, iced bunkers, and filled water tanks. Windows were washed in summer so passengers could enjoy Montana scenery, and within 10 minutes, trains were again swooshing on their way. This early experience triggered my long interest in electric propulsion. Today, I will share some electric transportation history and what I've learned from owning electric vehicles. I will conclude with some questions that we will face as electric vehicles are adopted in Montana. We have 8 other additional speakers in this webinar series that will help us understand the opportunities and issues of electric transportation. On your screen, perhaps there'll be a photo. There it is, National Geographic of October. It boldly declares the revolution is here. Overhead, we see electric drones and planes. On the ground is a train, a motorcycle, a pickup, and a freight truck, all led by a passenger car. These represent, as it says on the cover, the dream of a cleaner commute. This edition also provides lots of history and current information about electric transportation if you get a copy. Now let's contrast this photo with the Scientific American of 116 years ago, published in 1905. The caption is "The New and the Old, a Race Between Electric and Steam Locomotives." Scientific American did not print "cleaner commute" on their cover. Cleaner commute is instead implied by black smoke emerging from the steam engine. Then, as now, environmental issues were of concern. Smoke and soot from steam engines was a major problem in tunnels and stations. Fully electric locomotives mitigated that issue. The Scientific American also shows power poles, which point to the need of an electric grid. You can see the poles by the electric motor, and you can see some on the right as well. Many people do not realize that originally motorized vehicles were designed with electric motors or used steam engines. National Geographic tells us that in 1828, a model using a direct current electric motor demonstrated the potential of electric vehicles. In 1859, a French physicist invented the first rechargeable battery. And by 1881, a French electrical engineer fitted an electric motor and a rechargeable battery to a tricycle, creating the first roadworthy electric vehicle. By 1880, American inventor Thomas Edison laid 1,400 feet of track at his New Jersey laboratory for experiments with a small generator-powered electromotive. In the 1890s, the first commercial electric vehicles were sold. By 1900, 40% of American cars are powered by steam, 38% by electricity, and 22% by internal combustion engines. Inexpensive oil-based fuel for gas engines pushed electric passenger vehicles out of the market starting in 1910. Ironically, American electrical engineer Charles Kettering invented a starting system using an electric motor to replace hand cranks. This greatly advanced the convenience of automobiles and fostered the use of internal combustion engines. Just picture you or your spouse hand cranking a car in the middle of winter to see why the electric starter was such an innovation. Well, let's talk a little bit about electric transportation in Montana from the early days. As early as 1913, Montana was recognized as an ideal location for adoption of electric locomotives. The major reasons were mountains, got plenty of those, copper, lots of copper, and water. Electric locomotives are unsurpassed for hauling heavy loads over mountain ranges. And electric motors and transmission lines require much copper. Hydropower supplies that we have plenty of provide clean and inexpensive electricity. Montana has an abundance of these items, and for over 60 years was home to 2 of the most successful high voltage DC railroads in the world. These were the 26-mile Butte-Anaconda Pacific, hauling copper from ore from Butte to Anaconda, and the 647 route mile Milwaukee Railroad system, hauling passengers and freight over the Continental Divide. Although these 2 railroads, the BA and P and the Milwaukee, have gone, there are today many electric railroads in the world operating with technology perfected in Montana. It is important to understand that railroads in Montana and elsewhere today continue to use electric motors for propulsion. However, instead of overhead conductors providing electricity, Locomotives are powered by onboard diesel engines powering generators to supply electricity to drive wheel motors. Based on history, then, I think that the current push for battery electric vehicles, BEV as they say, is viewed as revolutionary by most people today, hence the cover on Geographic. During our lives, personal transportation has been powered almost exclusively by internal combustion using gas and diesel, and not based on motors powered by electricity. I also think it is fair to say that the current EV revolution of today is really that of matching big batteries to passenger vehicles, airplanes, and other applications shown on the Geographic cover. I also think that the agriculture tractors and self-propelled implements are missing in the Geographic cover. Such equipments are now being researched and manufactured. Montana farmers and ranchers will need help with decisions on how electric propulsion could benefit their operations. Excuse me. Let's turn now to our own electric vehicles and what we've learned. My wife and I purchased a hybrid gas-electric vehicle in 2010. It is still our primary long-distance travel automobile. Our hybrid has one gas and two electric motors, one electric motor on each axle. It has a very small propulsion battery that is good for about 1 mile of distance. The hybrid combustion engine shuts off when stopping at intersections, thus improving mileage performance. Gas motors also provide regenerative braking, or electric motors also provide regenerative braking, which recharges the drive battery. It is primarily a gas automobile. In 2017, we purchased a fully battery electric vehicle. The factory full charge battery range is stated at 238 miles. This rechargeable battery can be plugged in at home to charge at 120 or 220 volts AC. We primarily charge at home using a 220 volt AC welder outlet. We can also charge away from home using a commercial 440 volt DC fast charger. Last year, we drove 15,309 miles on these two vehicles, all in Montana. This was almost a 50-50 split, 8,000 miles on the gas-electric hybrid and 7,000 on the electric. Well, here are some experiences that we've had in owning these automobiles. Several friends and acquaintances have questioned my desire, and perhaps my sanity, for owning electric vehicles. It has been fun being teased about running out of electric fuel and challenging to answer questions about electric car use. Summarizing my own electric driving experience is simple. It parallels that of being transported on electric trains. To elaborate, battery electric vehicle transportation includes clean and quiet operation, economics of low fuel cost, less maintenance, coupled with excellent performance. My wife says this convenience is a major plus. Driving in stop and go traffic to attend appointments, run errands, or go shopping is enjoyable. The ability to charge at home out of the weather is also high on her convenience list. I agree with her that local driving is convenient. For the battery size in our car, we consider local as the area within a 100-mile radius of our home. Remember I said the 238-mile battery we had? Well, if I have 100 miles out, I still have more than 100 miles to get back. Overall, however, I do not, excuse me. Excuse me. Overall, however, I do not rate convenience as my biggest electric attribute. This waits until I can easily make long journeys anywhere in Montana. This will happen eventually when a sufficient number of charging stations have been constructed. Highest on my list for electric car driving is one-pedal operation. The inherent regeneration braking of electric motors makes this possible. One-pedal driving is simple. Pushing the pedal increases the speed. Release in the pedal causes immediate and controlled slowing or braking. The loss of the kinetic or moving energy causes the car to slow. Some of this energy is also captured to recharge the propulsion battery. Think free fuel. The use of regenerating brakes was a major attribute that favored adoption of electric locomotives hauling trains over mountains in Montana. Regeneration braking allowed those loads to descend from the top of the Continental Divide at a controlled and fixed speed while returning electricity to the grid. A test by the Milwaukee Railroad, conducted near Butte in 1916, showed approximately 15% of the power consumption to go up the hill was returned to the grid by regenerative braking. Regenerative braking also provides an additional cost savings in minimizing wear of pads and discs on mechanical brakes. I seldom have to apply mechanical brakes when using one pedal driving. Well, as stated, the objective of our seminar is to learn about issues and opportunities of adopting electric vehicles in Montana. This information is important to both rural and urban populations. The increasingly rapid rate of electric propulsion adoption provides us with a complex economic, social, and technical challenge that needs our attention and understanding. Here is why I think this way. I earlier stated that our total mileage was split 8,000 with gas, 7,000 fueled with electricity, kilowatt hours. Understanding this split is important. Our electric vehicles use impacts not one, but two critical Montana infrastructures. This is because of those two types of fuels. The electric grid primarily fueled 7,000 miles of electric car use. Using our average rate of 4 miles per kilowatt hour, we required 1,750 kilowatt hours of fuel last year. Electric cars impact not just roads and highways, driving over them, but also our electric infrastructure to obtain the fuel. Gas vehicles do not have a direct fueling impact load on the grid. Our mileage split also shows that the hybrid gas car was driven 8,000 miles, and our average is at 25 miles per gallon. This required 320 gallons of gas. The weight of 320 gallons is 1 ton. Fuel transportation to service stations is by tanker truck trailers hauling heavy fuel using the transportation infrastructure. Electric vehicles do not have this direct fueling impact on the transportation infrastructure. The impact of these different fuels on these two separate critical infrastructures must be considered as we go forward. The future of transportation in Montana and elsewhere now requires solving problems of both highway construction and maintenance and of reliable electric generation, transmission, and load capacity. All of this poses some questions for all of us. First, how do we pay for these infrastructures? If taxes continue to be based on fuel sales to support highway infrastructure, then how will future taxes be equitably collected and shared to finance both highways and power lines? Could we use a different taxation method, such as one based on actual miles driven? How would these miles be tracked? There are also social problems inherent in the electric vehicle movement. One can think of the job dislocation that occurred as horse and buggies transportation evolved into automobiles. Electric transportation is rapidly heading our way, and similar social issues are inherent in this process. What social problems will we face here in Montana? Technology is also forced to respond. Reduction of scarce minerals and recycling of big batteries comes to mind. What will electric supply look like in the future? Is it time again to reconsider nuclear power options? While Montana is not the only state to face these issues, I am confident that Montana has resources to find the best solutions for our state. I ask you to join me in carefully listening to the speakers in this webinar series as we undertake this educational journey. We need our best solutions to this complex economic, social, and technical problem for both rural and urban populations. Our understanding and participation in this with thoughts and questions is important if we all want a productive and equitable transportation future here in Montana. Thank you.
All right, Nick. Well, thanks for giving us that nice introduction. We do have a couple questions that I'm going to ask you before we move on to our next speaker. So the first one is, what is your experience on charging time for 110 versus 220 volts?
110 volts is very slow. Typically, you get about 3 miles in the battery, miles as listed in the battery, the kilowatt hours that are really in the battery. Whereas at a 220 volt, that works out to about 25 miles in that hour. That said, I can easily plug in at night with my 220 volt charger and have a full battery the next morning.
All right, one more question that's come in so far is, what has your experience been in terms of repair experience between your cars and maybe what you've owned in traditional gasoline cars?
Well, in the traditional gasoline car or hybrid, we still have oil changes. There's 1 or 2 a year, depending on our mileage. In the nearly 5 years we've had our battery electric vehicle, the only thing I've done on maintenance is to add windshield washer fluid. That's the only maintenance. There's no oil changes. There's plug it in at night. It's ready to go in the morning, and away we go.
All right, and well, I was talking, a couple more came in. So what's the magnitude of the effect of cold winter temperatures on range?
Range is reduced in the winter. Batteries don't like the cold. And there's several studies saying how much battery degrades in the cold. That said, one should understand that if there's energy in the battery, the electric motor will start in any temperature and will move it. You don't have to have an engine heater to heat the engine or to worry about plugging in that way. You have to be careful looking at your battery to know that it's full and be prepared. But yes, you do have some degradation in the mileage due to cold weather.
All right, well, we've got more questions, but I think we'll save those for the final panel, just to make sure we stay on time. We've got a big group today, and we've had quite a few questions come in. So Nick, thank you for the introduction there. Our next speaker is going to be Larry Flynn, and Larry, you should have the ability to share your slides if you'd like to do that and turn your camera on. And Larry is a administrator with the Montana Department of Transportation, and I'm sure that he's forgotten more than I will ever know about how roads and bridges are funded in Montana. So Larry's going to give us a little bit of a window into how that world works and maybe what some implications of a shift to some electric vehicles would be.
Yeah, thanks, Joel. Good morning, everyone. Yeah, Larry Flynn. I'm the CFO for the Department of Transportation. I've been with the department for nearly 28 years now, and most of that time spent with managing fuel tax and the finances of the department. So I'm probably going to take this in a little bit different direction than a lot of you might be tuned in for, but my goal for today is to kind of share with you the nuts and bolts of how transportation funding works in Montana, specifically how it works at the Department of Transportation. So I'm going to attempt to share my slides here. You should be seeing it now.
Yep, they look good.
Okay, great. So let's whoops. Little technical glitch there. Okay. So let's just start out with just an overview of what MDT does. Obviously, the meat and potatoes of what the Department of Transportation does is manage the 25,000-mile highway system throughout the fourth largest state in the nation. Anywhere from project nomination and selection to managing the in-house and contracted road and bridge design. So we are very engineering centric. right-of-way acquisition, the environmental review, the contract management of private sector road and bridge construction contractors. MDT has a very large budget, and about half that budget, somewhere between $400 and $500 million a year, will go to paying the highway and bridge contractors throughout the state. But we're also responsible for the maintenance side, the snow and ice removal, pothole patching, crack sealing, and of course, managing the commercial vehicle size and weight enforcement. Nick, you kind of alluded to the heavy trucks and the damage they can do to our roads, so that's a very important part of what we do. But the highway segment is just one of many. We do manage a multimodal transportation system, including airports, transit, rail, and even bike and pedestrian transportation to some degree, and much more than that. But obviously, to do this, we have to pay for it. So how do we pay for it? Well, about 30% of our expenditures are paid from state sources. So these are largely state taxes and fees. About 96% of the state funding that we receive at the Department of Transportation comes in the form of the highways funds. There's really three main highways funds. There's the constitutionally protected gas tax fund. That's affectionately what a lot of people call it. It's the HESRA account, the Highway State Special Revenue account, largely gas tax revenues. There's a non-restricted account, and then there's the BARSA account. The BARSA account is relatively new. That's the Bridge and Road Safety. I have a typo in there. It's Bridge and Road Safety and Accountability Act. It should be two A's, not two S's in there. But that's the additional gas tax, the gas tax increase that was passed in 2017, and that is solely dedicated for bridge and road construction and maintenance and can be used for nothing else. And we actually have to account for that separately, and that funding is split between the department and local governments. Federal special revenue. So these are the federal funds that come largely from FHWA. A huge chunk, about 2/3 of our funding comes from federal sources, and we use the state dollars to provide the necessary state match for that. And then we have some proprietary funds that are kind of impertinent to this conversation today. But if we look at that HESRA account, the Highway State Special Revenue account, this is the constitutionally restricted account. This is the constitutional language. I won't read it word for word, but essentially we are restricted constitutionally to spend those dollars on road and bridge construction and maintenance. That does provide, those funds do provide the primary matching source for our federal dollars. We have a very, very favorable match rate in the state of Montana. About 87% of those dollars are matched with 13% state. A lot of states are more of like an 80-20, but Montana is very favorably positioned to get that better match rate. We receive 400 million plus, and this slide is a little bit outdated. Of course, we had the new infrastructure bill that just was recently passed, but we get in addition to or in excess of $400 million per year annually in federal funds. And we do spend those funds for the planning, design, right-of-way acquisition, and construction. And one important note is that we work on a reimbursement basis, meaning that we have to spend our state funds to perform the federally aid eligible work, and then we bill them after the fact. So we have to have enough cash flow within that fund to kind of float those federal dollars until they come in from FHWA. And then the largest spend of our state dollar is actually on highway maintenance. The maintenance activities, the plowing, the sanding, all the patching, the guardrail repair, all of those things come out of the state dollars. They are not eligible for federal reimbursement. But we also are required to have a certain level of maintenance of effort to receive that federal match. So if you look at the revenue sources for HESRA, about 2/3 of them come from motor fuels, either gas or diesel tax. The GVW, so the gross vehicle weight, the commercial vehicle revenue for permitting and licensing does come to us. That's about 11% of the HESRA funding, and then the feds actually participate in our overhead costs as well. So we get about 21% of our revenue is from reimbursements from the federal government for our overhead costs, our indirect cost recovery. Looking at the uses of that fund, if we look at it from the budgetary programs, you'll see on the right side there's about 27% of our state dollar that goes to the construction program. Most of that is for match on the federal aid program, where you can see more than half of our spend of the HESR dollar goes to maintenance. So although construction is a much larger program in terms of total dollar output, the state spend for that construction program is relatively small compared to the maintenance program. So diving in a little bit more into gas tax itself, motor fuels tax, obviously the per gallon tax, we collect the gas tax from the petroleum distributors throughout the state. There's about 135 distributors. They file tax returns with us on a monthly basis. So we have a fairly stable known revenue source. We know about once a month we're going to get our fuel taxes from these distributors. The gas tax bill, House Bill 473 in the 2017 session, that added that BARSA funding on top. That's designed to kind of increase incrementally over a period of about 6 years, starting in fiscal year 18 all the way up through 23. We're sitting there at a 32.5% gas tax rate now. Diesel tax was taxed at a little bit lower increase, if you will. That's sitting at just under 30 cents a gallon right now. In addition to the gas tax, there's also a 0.75 3/4 tax per gallon that goes into the petroleum storage tank cleanup. And that's administered at DEQ. So where does the gas tax go? The gas tax formula is pretty easy. You have the number of distributed gallons multiplied by the rate, and that's your total revenue. About 8% of that total tax revenue goes to what we consider off-road programs. There's a distributor allowance that the distributors, in exchange for collecting our tax for us, since they collect at the retail level, they actually retain 1% of their tax revenue, so they get to keep some of that. We also have many refund programs for fuel that's used off-road, since the intent of the tax is to pay for the roads and bridges throughout the state. The primary refund segment is on agriculture use. So the fuel that's being burned, the tax-paid fuel being burned in off-road agriculture use is subject to a refund. And then there's some drawdowns off the gas tax that go to some off-road accounts at Fish, Wildlife, and Parks for things like snowmobile trails, for instance. The snowmobile community burns tax-paid fuel in their snowmobiles, although they're driving them off road. So there's a percentage of the gas tax that goes to support those programs. The Montana Highway Patrol gets about 4 cents of the gas tax that goes into their operations to help pay for the patrol activities throughout Montana's highways. Local governments also get their share of the gas tax. They get about 14%. There's a statutory dollar amount that's written in permanent law of just under $17 million that gets distributed out to each local government. And then, of course, the new BARSA money that was passed in 17, they get about 65% of that tax revenue goes through the same formula out to cities and counties. So at the end of the day, there's about 66%, about 2/3 of the gas tax revenue that ultimately finds its way to MDT into the HESR account or the BARSA account. Where do we sit with our gas tax rate? Well, we're about middle of the pack. If you look at fuel taxes across the nation, we are 23rd out of 50 states in terms of our gas tax rate. So that's not bad. We're right in the middle. If you look at our surrounding states, though, we're a little high. We're sitting there at just under 33 cents. Only Idaho is slightly larger or slightly greater in terms of our gas tax rate. But this is only part of the picture. One thing that we've been looking at recently is the dependency on fuel taxes. And Montana is very dependent on fuel taxes. This chart shows you those deep red bars at the bottom. That's the percentage of transportation funding by state that comes from the federal government, from FHWA. The lighter orange colored bars represent the state motor fuel taxes. So you can see that Montana, if you look at just our federal uh, income, which of course is derived from the federal motor fuel tax, you'll see that between the federal and state fuel taxes, we're sitting at about 95% of our transportation funding, 96% that comes from uh, either federal or state motor fuels taxes. Some of these other states have sales tax, general fund. They have a variety of other uh, uh, revenue sources, oil and gas royalties and the like. They have other sources of revenue that they dedicate towards their infrastructure. Where Montana, we are very, very captive to the motor fuels tax. So that orange bar at the top, that's the Hezra and Barca funding. That's the state gas tax that goes to pay for our state match. So when we're looking at revenue trends, there's kind of this ongoing cosmic battle between vehicle miles traveled and miles per gallon. So fuel economy versus the increase in traffic that we've seen. It's been kind of a roller coaster ride. Of course, a couple of years ago when we were all hit with the prospect of COVID and travel pretty much shut down, we got very, very nervous in terms of what that was going to do to our fuel tax revenue. In fact, at the time that COVID first hit and there was a lot of stay-at-home orders, we projected about a $72 million revenue loss in gas tax. And of course, you've all been around the state. You've seen kind of what has happened, and traffic has just exploded everywhere. So we actually recovered fairly nicely from COVID in terms of miles driven. But over the last 25 years or so, we've seen about a 40% increase in vehicle miles traveled throughout the state. So that averages out to about 1.6% increase per year. So that's pretty good. We're doing well there. Of course, that gets tempered a little bit when we start looking at fuel economy, and that's kind of the tie-in to this topic. But if you look at what's gone on over time, of course, CAFE standards, that's the dashed red line in the middle there. That's, CAFE standards are going up for sure. The solid red line, though, represents the actual average fuel economy of new cars produced in the US. So manufacturers have actually been producing cars above the CAFE standard for quite some time. But that gap is closing, as you can see. But keep in mind, this only goes out to 2017. We all know that that's changing rapidly as we step into the future. But that's new car production. If you look at what's the cars that are actually on the road, you'll see that increase in fuel economy is actually more sluggish than that. Obviously, because there's older cars on the road as well as the new cars. Nationwide, the average age of the cars nationwide is about 11 and a half years old, but here in Montana, the average age is over 16. So we will actually see, based on this anyway, we would actually see a slower um, uh, gain in fuel economy in our overall fleet than we would nationally. So you have that battle between mileage and fuel economy, and in the end, that translates into how many gallons of fuel are we selling each year. We've seen some decent growth over time. We average about 2.5%, slightly larger than 2.5% growth in diesel. Of course, some of that includes the Bakken boom. We saw huge increases in diesel tax sales when we had the Bakken oil boom in eastern Montana, and of course that's slowed down some now. But on average, we're about 2.5%. Gas is a little more sluggish. Historically, this has held true for decades that gas will grow at about 0.5% a year. So overall, between gas and diesel, we're at about 1.2% growth in taxable gallons. So still growing. Gas tax, although we hear all the downside of motor fuel taxes, the revenue is growing, but is it growing enough? At 1.2%, there's a strong argument that says that we're losing some buying power there. So when we look at the impact of electric vehicles, and as you all know, there's been a couple of attempts at legislation to take on the registration fee on electric vehicles, and most recently, I can't remember the bill number, but the 2021 bill passed through the legislature and was vetoed because the costs were astronomical. The fees that were imposed were substantially larger than probably what was needed. But just to kind of put it in perspective, and again, there's a lot of discussion and debate and policy initiatives and tax structures, and there's just a lot to take on to get to the point where we can really look at electric vehicles as a viable revenue option. But if you look at just kind of the gas model, so for a gas-powered vehicle, making some assumptions here, if on average we're looking at 12,000 miles that were driven in a car, and say you're getting 25 miles to the gallon, which is a fairly good average, your annual fuel consumption would be $480, or 480 gallons, pardon me. So if you look at the price of a gallon, if it's say $3.40, and obviously that fluctuates quite a bit, you're going to end up spending about $1,600 in total fuel for that gas-powered car, including $156 in state taxes. Okay, now that's not the federal tax, but just the state taxes is $156 and $88 in federal taxes annually. Okay, so if we look at the same model for an electric powered vehicle, same assumption, 12,000 miles a year. A little bit of light research showed that the average fuel economy on current electric cars is about 3.3 miles per kilowatt hour. Okay, and there's a large range there too, but we picked something kind of in the middle. That would put your annual electricity consumption for those 12,000 miles at about 3,600 kilowatt hours per year. Okay, so the total cost, of course, now there are no state taxes currently on those electric vehicles, nor the tank cleanup fee, the federal fuel price, nothing. Right now, and again, this fluctuates a little bit, but about 10.7 cents per kilowatt hour would be the price of that electricity. So your annual cost would be just south of $400 a year, about $389, $390 a year. So if we were to now look at that same model, obviously, in order to replace the gas tax that is lost, we would just be simply looking to replace that $156 a year. That would be, in our mind, an equitable share of the transportation funding. So if we could ever, and I get it, there's a lot of regulation, a lot to work through, but just mathematically, that would average out to about 4.3 cents of state tax per kilowatt hour to replace that funding. And as Nick alluded to, and we've had other discussions at the Transportation Interim Committee and some other legislative bodies, there's a lot of steps to go through here. We're on step 3 of about 420 to really get to a model that's going to work. But you know, that annual state tax, if we're targeting that for the registration fee, I think that's a good start. But there's obviously a lot of equity issues that go into that as well. But just mathematically, that's kind of how things would work out. But now flipping over to the expenditure side, just some pressure points on what's going on there. If you look at our federal aid program over the years that we match with our state dollars, we've seen that over the last 20 years or so that there's been an average growth of about 4% just on our federal aid program. which of course translates to a 4% growth in our state match requirements. One of the interesting things mathematically, if you look at this, is if the federal tax is also derived from selling fuel as the state tax is, and our state tax is only growing at 1.2, or our taxable gallons anyway, are growing at 1.2% a year, how is it that the federal government and the federal aid and highway program is expanding at 4% per year? Well, the short answer is we overextend the fund. They obligate more to states than they have in revenue coming in, and in the end, they've had to transfer since 2008. There's been $154 billion of federal general fund transferred to the Highway Trust Fund to keep the federal gas tax afloat. That represents about 25% of all revenue coming into the federal trust fund is coming from the general fund, and not from federal motor fuel taxes as it was intended. We were quite proud of the fact when we went into the 2017 session that we hadn't sought out a gas tax increase in 25 years. That same time frame applies to the federal gas tax. 1993 was the last time that the federal gas tax was raised. So there's holes in the federal fund, holes in the state fund. The other thing expenditure-wise that hits us is of course inflation. And a lot of folks will look at the CPI, the Consumer Price Index, which is right around 2% a year. But really, the highway construction is more subject to the National Highway Construction Cost Index, which is another economic indicator, and that raises about 6% a year. So we are seeing tremendously higher inflation in construction costs than other segments of the economy. So that's an obvious pressure point. Our funding is fairly fixed. From the federal perspective, it's growing at about 4% a year. State gas tax is about 1.2% a year. So we are losing buying power. We are literally, our fund is growing, so we have more resources. But those resources are stretching thinner and thinner. We can't stretch them as far. So in a world where we are expected to do more with less, we are literally doing less with more, just because of the inflationary pressures. More good news, of course, the IIJA bill, the federal infrastructure bill, was passed recently. If we look at the additional match requirements, including the discretionary programs that are included in that bill, and the redistribution dollars that we get on an annual basis. These are dollars, federal dollars that other states were unable to use, and they get redistributed to the states that can, Montana being one of them. We see an increase of about $26 million a year in state matching requirements that we're going to see going forward. So that's going to be an additional strain on our state tax dollars. And obviously, we are actively looking at what other efficiencies within the department we can save some money on, so we don't have to have a full $26 million revenue solution. We're hoping that we can generate some savings to get there as well. So if we look at this and look at kind of inflation going forward, this graph shows you that's kind of our projections based on our current level of expenditures. We know it's going to be more expensive in the future to maintain and build our roads. So we are expecting some growth. And now we add on top of that this additional match requirement from the new bill, and you see that our expenditures will increase even more so. So if you compare that with our projections in revenue on the state side, you see that our expenditures are going to where before we were more or less in line with our expenditures and our revenue. Now with the expanded federal aid program, our expenditures will far exceed that revenue, and we'll need to deal with that at some point. Bottom line though is we have tremendous needs in terms of our infrastructure. We've got aging bridges and roads everywhere that are going to need attention. There's some studies that estimate our total needs over the next 10 years to be nearly $16 billion. So, $1.6 billion a year over the next 10 years, where our available funding is less than $6 billion a year over that same 10-year time frame. So where's the balancing act? Do we really need 16 billion? Well, the truth is probably somewhere in the middle. We know that we are underfunded. We have to find that optimum balance. Where is the sweet spot for us to invest in our infrastructure to deal with our most critical needs while not breaking the bank in terms of our taxpayers? So looking at different options for transportation funding, couple of things that we've been tossing around here, just kind of philosophically. If we are looking at fuel tax adjustments, kind of the rule of thumb is for every penny of fuel tax, we would generate about $8.5 million in total tax revenue, which means about $5.5 million would be coming to MDT for every penny that we generate in gas tax revenue. The pros of that approach are gas tax is well established. It's a very simple, cost-effective way to manage our funding. Like I said, we receive our gas tax from 135 licensed distributors on a monthly basis. It's a really easy way for us to collect tax, and those gas tax revenues historically have been fairly predictable and stable. On the downside, well, it's a tax, and nobody likes additional taxes. I know I don't. And of course, it is fossil fuel dependent, and that does not seem to be the way that our technology is taking us. We have looked at indexing fuel to inflation. And again, just kind of rough back of the napkin calculations, we expect that we could generate nearly $3 million for each percentage point of inflation or indexing that we would impose. Again, simple for us to adjust the tax rate. The process is all in place, so it's very simple to administer, and it would keep a little bit better pace with inflation. But it's still a tax. It's still fossil fuel dependent, and some of those methodologies to determine that indexing could be fairly complex. We have talked about registration fees on hybrid and electric vehicles, specifically electric. Our suggestion would be about $156. That would be, we feel, a fair sharing of the infrastructure cost. But the kind of the downside of the registration fee is it still just targets a very minor population right now. It does disregard other advancements in fuel economy. So at the same time, we're talking about imposing a registration fee on electric vehicles. Every vehicle is more fuel economical. So we're missing the boat. There's other advances in fuel economy that we're not capturing by this methodology. And of course, it does discourage environmentally friendly behavior. The other thing is, with a registration fee, you're only capturing that from your in-state drivers, where most of our electric vehicle traffic, we feel, is still coming from out-of-state folks, and there's this registration fee doesn't capture that usage of the transportation infrastructure. Again, we talked a little bit about, could you charge at the electrical level? Very, very, very complex to do, and I think we're very early in that exploration, and there's a lot of discussion to have. But again, mathematically, about 4 and 4.5 cents per kilowatt hour would be kind of the sweet spot to hit there. The other thing that we've heard a lot about, of course, is the road user charge. The mileage-based tax, there's a lot of pilot programs, a lot of fully implemented programs, a lot of funding from the federal government through IIJA to explore this methodology. That would be, all things held equal, that would be a more equitable way to distribute those costs. And of course, if you're charging by the mile, none of that is impacted by fuel economy. So we don't have to worry about that anymore if we could charge by mile. However, that methodology is a long way off. There's tremendous administrative complications to administering that kind of a tax. It would be very labor intensive, very technology intensive, and at a substantial cost. Some of the reports that I've read show that somewhere between 17 and 25% of your tax revenue would be needed just to administer the tax. It's a very, very costly methodology. And is this equity issue of concern? Yes, but it's a far distant concern to the idea that we are substantially underfunding our infrastructure. So while it's important, I for one can recommend we go that direction and channel a bunch of our tax revenue off of the highway and put into administrative costs. There's the obvious privacy issues if we're going to tax per mile and equitably distribute those revenues to the jurisdictions or the states that you've driven in. We have to know where you've been. So if you're driving in Montana, we have to know which miles were driven in Idaho and Canada and everywhere you've been, so that we can equitably distribute those dollars. And the big thing is it's an unknown. We don't know what that modeling looks like yet. So I think the road user charge is a ways off. We are actively participating in a group of states that are exploring this as an option. But again, I just don't see that coming anytime soon. But maybe someday down the road. Anyway, that's all I had. Joel, I don't know if there's questions coming in yet, or if you want to wait till the end, or.
We do have at least 3 so far I want to start you with. Or 3. I'm going to combine a couple into one because they're related. But let's start with the easy one first. Why are vehicles in Montana 16 years old on average and everywhere else they're 11 years old?
I'm not sure. I can't speak to that. I can speculate. That I can't remember the source of that data, but I think it's from the Auto Alliance website. But I speculate it's because of our rural nature, right? We have a lot of old hunting rigs and people that just drive cars until they fall apart. We're very economically minded in Montana. We're very much function over form. So for us, if we've got that dependable car, I know I know of the four vehicles I own, 3 of them are permanently registered. They're that old, and my 4th one I could do next year. So I just think it's a cultural thing. We tend to drive our cars a lot longer, and beat the heck out of them. To be frank with you, I think we just culturally that's where we are as a state.
All right. I do still get calls though for my 91 GMC pickup that my factory warranty is about to expire. So maybe
Yeah.
there's still hope that it's a good vehicle. So
Yeah, no doubt.
so here's a couple questions, and I know you addressed a bit of this kind of after these questions came in, so maybe you can add a little bit. But do other states use inflation to adjust their tax per gallon tax to kind of keep up with the inflation costs of building and maintaining roads? So there were a couple questions sort of roughly around that topic.
There are other states that do that, with kind of varying degrees of success. But and they index them to all kinds of different things. Um, Something that appeals to me, and again, without a lot of exploration, I don't know how viable it would be, but a simple inflationary index like a CPI doesn't get you there. And one of the messages I would be concerned about, and talking with some of our legislative partners recently about this, I think those suspicions have been confirmed, but I would hesitate to say that we can index fuel and think we fixed the problem. And I think that would be the thought, would be that if we tie you to inflation, then we never have to talk about fuel tax again. We never have to talk about transportation funding again. But again, if CPI is only at 2% and we're actually realizing 6% inflation on construction costs, that's not going to get you there. And it also doesn't account for things like the new federal legislation where we suddenly find ourselves with literally a 20% increase in our federal uh, uh, revenue coming in and no method to adjust for that. But yes, there are a number of states that do that. There's some good success stories. There's also been a couple of states that have gone to a strictly percentage-based tax. So rather than Montana and most states, it's a per gallon tax. It's flat no matter what the price of gas is. You're paying X cents per gallon. Some states did try to move to a percentage, and there's more tragic stories there than success stories. One of the states put in their percentage when fuel was at $3 a gallon, and within 6 months the price had dropped to like $1.50. So they literally lost half their revenue stream. So there's some cautionary tales there, yes, but I think it's still a viable option to look at and explore at some point.
All right, thanks. I'll give you one more, and then we'll hold the rest till after Kayla speaks. But what kind of technology could you use to compute miles traveled on Montana highways as a source of revenue? So I'm assuming that might be for out-of-state vehicles or for maybe electric vehicles.
Yeah, so there again, it gets down to your in-state travelers. You can use a variety of technology, right down to just simply self-reporting. That's what a lot of the models are based on, are self-reporting. So maybe when you file your income tax or when you go in to pay your registration or something, you're reporting the number of miles you traveled and paying the tax, mileage-based tax on that. But again, that only works well for your in-state traffic, and you're missing your out-of-state traffic. There's lots of technology built, especially any cars in the last 10 or 15 years, all have the technology to turn on that tracking mechanism and capture those dollars. But you have to have the analytics to go along with that. Some of the models, like in Oregon, there's actually a transponder at the service station. So you pull in to fill up your car, and there would actually be a communication between the vehicle and the transponder in the station that would calculate your mileage since you last filled up, and you would pay that mileage-based tax at the pump. So there's technology out there, but again, it's quite costly. And you look at just rough numbers. Right now, we collect from 135 taxpayers, the distributors, and we have a well-established relationship with each of those, so it's fairly seamless. You go to a mileage-based tax, and you have to have some methodology now to collect from literally every motorist on the highway. So not just the several 100,000 Montanans that are on the highway, but folks from Wyoming and Canada and Florida and maybe the UK and rental cars and what have you. There's tremendous complications in doing that. So some of those technologies are still emerging, but some of them are there. They're just still fairly clunky and difficult to deal with administratively.
All right, well, thanks. And I think we'll hold the other questions for now. We had a couple people comment on why our vehicles are so old. It's we don't have enough salt air and humidity and salt on the roads to eat our vehicles up. So,
okay, well, we'll take that up. Just anecdotally, Senator D. Brown, who's termed out now, she was always trying to get us to take more salt or use less salt on the road. So maybe there's a happy medium there somewhere. So thanks. I'll wait for the end, Joel, for the rest then.
all right, well, thank you very much. So, all right, well, let's get to our third speaker here, and you're already seen her slides, and they look great, so that's good. So we have Kyla Maki, who's with the Montana Department of Environmental Quality as an energy resource professional. Apparently that's a hard word for me to say today. So she's a real expert and knows a lot about where vehicles are in Montana, what type of vehicles we currently have. So kind of how many people have taken advantage of these technologies. So with that, I'm going to turn it over to Kyla.
Great. Good morning, Joel. Can you hear me okay?
Sounds great.
Great. So My name's Kyla Maki. I'm with the Energy Office at the Department of Environmental Quality. Gonna chat today, just kind of lay of the land of electric vehicles in Montana, some information about charging stations, and then talk about some of the barriers in Montana to electric vehicle adoption and what we're seeing. Just a brief background on the Energy Office and our involvement in electric vehicles and alternative fuels. The Energy Office, with funding from the U.S. Department of Energy, has a history of tracking alternative fuels in Montana, policies, programs, and more recently with the increased interest in electric vehicles, electric vehicle adoption in Montana and across the country. We've been sort of tracking and planning and have some funding for electric vehicles and charging stations. So first of all, just some basic definitions and of what we're talking about when we're talking about an electric vehicle. Three different kind of terms get used. The first is, of course, a battery electric vehicle, or a BEV. That is what runs only on electricity. Those vehicles have ranges now from 150 to 300. We're starting to see ranges beyond 300 miles now with some of the new models that have been announced and coming out. Examples of that, most commonly, of course, Tesla, everybody knows. The Chevy Bolt, Nissan Leaf is another example. There's a lot more of these all-electric vehicle models that are coming out, going to be on the market. Then there is the plug-in hybrid electric vehicle, or PHEV. It can run on either gas or electricity. The battery sizes can range between 20 to 50, maybe a little bit even higher than that. But that's your Chevy Volt, Ford C-Max Energy, the Toyota Prius Prime. There's a handful of examples of those, and right now, with kind of limited charging options, plug-in hybrids are a good option for Montana, just to be able to have that gasoline engine as kind of a range extender. And then there's hybrid vehicles, which classic Toyota Prius. They're not charged from an external source, and the battery can't really be used to get that vehicle range, but those have been around longer. So then some charging station terms and differences. There's three different levels of charging stations. So your level 1 charging is your classic 120 volt. You can plug it into any outlet in your home or garage. That's the slowest level of charging. You get about 2 to 5 miles of range per 1 hour of charging. The primary use on the level 1 is, of course, residential. And, in fact, about 80% of charging for electric vehicles occurs at home. And so this is an easy option for those who may not be able to install a faster charger at their home and want some cost savings there. Then your level 2 charging station is kind of the next level up. It's the more like a dryer outlet, 240 volts. You get 10 to 20 miles of range of charging per hour. This can be residential or commercial. The cost range, just depending on, especially if you're putting these in at a commercial site, you may need to run conduit electrical to install the charging station. So this is an option great for places like restaurants or, hotels, places where the vehicle may be parked for a little bit longer. And a good use case for a lot of options for kind of adding to tourism and businesses wanting to bring people into their business, this level 2 charging station, and still fairly affordable. And then, of course, there's the level 3 or DC fast charging. These you would use for, just commercial applications, much higher speed of rate of charging. You can get 60 to 80 miles per 20 minutes. There's even faster options available. just a note here that within this level 3 category or DC fast charging, there is also a wide range of capacity or charging, how fast a vehicle can charge even within this level 3. So you have anywhere starting at 50 kilowatts, and now we're seeing chargers up to 350 kilowatts. So quite a larger draw for some of the higher, faster charging level 3 stations. And then just real briefly, connector types, you can see that for the DC fast charging, there's 3 primary different connectors. So you have the Tesla connector, which can only be used to charge Tesla vehicles. That's at their supercharging stations, which you've probably seen around Montana. And only Tesla vehicles, again, can charge on those. And then you have the CHAdeMO, which a lot of the Nissan vehicles charge on. And then the most common type is the CCS combo, which any vehicle can charge on, and even Tesla, because they have an adapter to be able to charge on the CCS. So for the electric vehicle registrations in Montana, this is something that we gather data annually from Motor Vehicle Division, and then there's a website, Atlas EV Hub, that provides us information on which of those vehicles are plug-in hybrids and which are all-electric vehicles. And so you can see that this is very recent data. As of this month, we pulled the registration data, and we have currently 1,800, just a little over 1,800 battery electric vehicles, so all electric, and then 1,002 plug-in hybrid vehicles. And then the darker green counties are where there's more EVs registered. And you can see that Flathead County is number 1, Missoula County is number 2. I have that flipped there on the slide, sorry. And then Gallatin County is number 3 in the state. So the and just to put this in context a little bit, this is out of over about 1.6 million light duty vehicles registered in the state. So still very small percentage of vehicles. It's just under 0.5% of the vehicles registered in Montana are electric or plug-in hybrid. The other kind of trend that we're seeing is more of these vehicles are on the all-electric side than the plug-in hybrid side, and I think this is due in part to more availability of charging stations, and then the costs of the all-electric vehicles coming down, like even the Teslas are becoming more affordable. So those options are more available to folks who can't afford the higher end electric vehicles. And then just as some additional background on kind of comparing the emissions of electric vehicles compared to gas or hybrids, based on Montana's electricity mix, is you can see that of course the all electric is less than half of the annual emissions, and this is well-to-wheel emissions. So they're looking at the electricity mix. Tailpipe emissions, of course, are a big component of the gasoline engine. This information comes from EPA, and so the all-electric has about half the emissions as the gasoline-powered vehicle based on Montana's electricity mix. And first, that this is an average, and so every utility in Montana is going to be a little bit different on what sources of electricity they're using and delivering to customers. The second is that this is electricity generated in the state, so not necessarily consumed. It's just average from this EPA data, but just a background on the emissions comparison if folks are wondering, what are some of the environmental emissions benefits in Montana. So moving into some barriers to electric vehicles in Montana, there's 3 primary barriers. I think Larry touched on some of the concerns about fuel tax issues. some of the, just where the technology's at, especially with Montana's large geography and small population. There's some of these challenges aren't necessarily unique to the state, but they're kind of exacerbated. So the first is range anxiety, and this is a term of art that's becoming more known, but it's essentially that your vehicle's going to run out of battery before you can charge up again. And this is more applicable to those who are, using their vehicle to travel long distances across the state or for visitors coming to Montana. So the range anxiety is a concern. And model availability ties into that, just what vehicle models are available, what is their range, but also the types of vehicles that are available that, compared to what Montanans typically purchase and use. And then finally, the cost to charge, that's a big one, especially in a rural state. And this specifically relates to on the DC fast charging station side, just some of those cost considerations, especially while usage is low, something to think about. So on the range anxiety barrier, this is the current state of public charging in Montana. So this is from the Alternative Fuels Data Center with the US DOE, and you can go there and find charging stations that are available. I selected for only non-Tesla publicly available DC fast charging stations. So you can see there's 10 station locations, 22 ports. So that's each kind of plug on the DC fast charging. So these are at least 50 kilowatt stations. You can see they're mostly in Western Montana. There's one in Bozeman, we've got one just outside of Butte in Rocker, then going south, one in Dell, just over the Idaho-Montana border, and then up in northwest Montana, Kalispell, Whitefish, and there's a couple in the Missoula area. So very limited right now to Western Montana. Just a closer look at some of the stations that have been installed. These are, again, fast charging stations. There's one in Polson, actually. These are stations that, this is one of the stations that the DEQ helped fund through Volkswagen settlement funding, which I'll talk a little bit more about. There is a brand new one in Gardner at the Sinclair outside of Yellowstone National Park. And then here's an Electrify America station in Rocker that I mentioned. Just provided a picture of a Tesla supercharging bank of Tesla superchargers just to show what that looks like. And then the one in Bozeman is at the Bozeman Audi dealership, again, publicly available, and any vehicle can use these stations to charge. So that's where things are currently with the charging stations in Montana. This map just shows the planned electric vehicle fast charging stations. The gray circles are those stations that are 15 stations that are being funded and have been announced through DEQ's funding, Fast Charger Ride grant program. That funding comes from a Volkswagen settlement from 2017. And those 15 stations are along I-15, I-90, US 93, and a couple along US Highway 2 in Northwest Montana. And so those are anticipated to be online end of 2022, I believe, early 2023. There's also additional private investment that's planned in fast charging stations in Montana. So there's 3 planned DC fast charging stations at town pump locations in Billings, Boulder, and Whitefish, and then 2 planned Tesla supercharging locations in Custer and Shelby. And I mentioned the Tesla stations because there is some talk about Tesla opening up their network to non-Tesla drivers. And so that would expand some opportunities in Montana for fast charging if Tesla does open up their network. But currently, these are the planned stations that are publicly available and available to all EV drivers. In addition to some of the state planning, in order to address some of the concerns about range anxiety and to coordinate with other states, Montana does participate in Regional Electric Vehicle West group, which there was an MOU signed between Montana, Wyoming, Idaho, Utah, Nevada, Colorado, New Mexico, and Arizona, just to help communicate on progress related to DC fast charging stations, some of the challenges, things like concerns about fuel tax, facilitating EV travel, supporting economic development and tourism was an important goal of coordinating at a regional level. Sharing information and collaborating on, any funding opportunities as a region to support electric vehicle infrastructure and address some of the barriers. And then kind of at a national level to help address the range anxiety and plan for the build out of DC fast charging stations. Montana has designated several corridors under the FHWA's Alternative Fuel Corridor Program as corridor pending. And what that designation means is that there's not yet sufficient infrastructure, but the state is, making plans to figure out how to install and work with private entities to install fast charging stations along key corridors. Those corridors in Montana that have been designated are I-15, I-90, I-94, US Highway 2, and US Highway 93. And every state has designated corridors for EV infrastructure. In the last 3 rounds of nominations, and Montana's included in that. And previously, there had not been funding attached to the Alternative Fuels Corridor Program, but with the new infrastructure funding and the infrastructure bill passed at the federal level, there is funding and prioritization attached to the designated corridors for the state. So a little bit on that is that as it relates to EV charging stations, the Infrastructure Investment and Jobs Act includes $7.5 billion for EV charging stations. $5 billion of that is going to the Highway Formula program, and $2.5 billion is for EV community grant funds. The guidance for each of these programs is still being worked out through FHWA and U.S. Department of Transportation, but Montana is expected to receive about $43 million over 5 years, about $8.5 million a year in the formula funds, and that's dedicated for EV charging. The priority, again, is for FHWA designated EV corridors, focus on rural areas, and there is a focus with this funding, on the rural areas and underserved communities to help kind of develop this network of charging stations. Also, to one of the positives in helping address range anxiety is that the electric vehicle range has increased over time as battery capacity and technology is improving over time. So you can see that in 2015, up until 2015, the range was under 100 miles for the median range of an electric vehicle. That takes a big jump in 2016, and now in 2020, we're seeing the median range of these vehicles be over 200 miles. And as I mentioned, there are several vehicles that have been announced with that will be coming out over the next couple of years with a range of over 350 miles. There's also more electric vehicle options that have become available over time, and hybrid electric as well. But we're seeing, you know, that trending upwards, that there's over 125 models total between hybrid electric and all electric vehicles available in 2019. That number is increasing. The other note on this is that, and of interest to Montanans, because 40% of the light duty vehicles sold in Montana are pickup trucks. And there are, I believe, 38 models of pickup trucks or SUVs that have been announced or are available on the market for all electric options. So the model availability is increasing, and most folks have heard about the F-150 Lightning, and that is highly anticipated, and there's a lot of interest, and especially in states like Montana who like their pickup trucks. Here's just some pictures of some of the passenger light duty electric vehicles that are available. The F-150 Lightning is in the top left there. Then there's the Volkswagen ID.4. The Rivian is another pickup truck option that's going to be available to the general public, I believe, starting next year. Then, of course, the Tesla on the bottom right there, and the Ford Mustang Mach-E on the far left is another sedan option. So I mentioned another barrier was the cost of charging, and you know, one of the challenges of the cost of electric vehicle charging is that it really varies from location to location. It's hard to say, you know, it costs this much to charge at this location. It depends on, you know, which utility is providing service to the station that you're located at. And again, this is geared a little bit more towards the DC fast charging stations. But it's a challenge, especially with low usage and, you know, low adoption early on, especially in more rural states like Montana. And so what this table shows, and this is from a report that was just released at the end of in fall of last year for the Intermountain West on kind of average cost to charge an electric vehicle at fast charging stations of different capacities, depending on the usage per month. And Montana was one of the states they looked at. So they looked at for the top 5 utilities in the state, how much on average it would cost per charge. So for a 50 kilowatt station, you can see that at just 4 charges per month, that's $140. If you're using a 300 kilowatt DC fast charging station, the cost per charge at that low usage is $670. So, and this is, a lot of this is due to what are called demand charges, which are trying to reflect the impact on the grid, and there, in addition to like the per kilowatt hour charge on the bill, there's a demand charge, and the demand charge is kind of the highest 15 minutes of usage over a month. And so a lot of these charging stations have a large draw over a short period of time, and so the demand charge can be a significant portion of the bill. I think the average for the states in this report, the average portion of the bill was about 76% of the bill for the DC fast charging stations was associated with the demand charge. So this is definitely a challenge. In addition to some of the upfront costs, these operating demand charges can be a challenge with low adoption in rural areas. So I've spent quite a bit of time talking about the light duty vehicle side. I did want to just briefly touch on the kind of the medium and heavy duty. It's an important category that there's more vehicles that are becoming available I mentioned the Volkswagen funding. DEQ administers the Volkswagen funding in Montana. It came from a settlement that came out of Volkswagen cheating emissions tests. Back in 2017, Montana received $12.6 million. 15% of that it's going towards charging stations, and then the bulk of it is going towards replacing medium and heavy duty diesel vehicles with newer diesel, alternative fuels, and electric options. And here's just another summary of the Volkswagen settlement, but the goals of the program are to reduce mobile source NOx emissions and invest in clean alternative fuels and infrastructure, and also achieving long-term air quality benefits for the greatest number of Montanans. And so we have provided grants to several different entities, local governments, universities, private entities to replace medium and heavy duty vehicles with, as I mentioned, newer diesel, alternative fuels, and electric options. And on the medium and heavy duty side, there's also this is to point out there's more and more options that are being available for vehicle applications and with electric options. So you can see there's an electric ambulance that's available. Mountain Line in Missoula has electric buses. There are garbage trucks that are fully electric. I know Idaho is operating a few all-electric garbage trucks, street sweepers, school buses, and other applications such as utility bucket trucks, service equipment. So there's more and more of these medium to heavy duty options that will be available, and an opportunity for this sector to electrify fleets and provide economic environmental benefits to those who are using these vehicles. So I think that's all I had, and there's my contact information if anybody has any questions. And yeah, happy to answer them.
Well, thank you, Kyla. We've got a handful of questions, and then I'll kind of bring the other panelists in. We've got a few there as well. So a couple for you first. Other than Mountain Line buses that you mentioned there, this question came in before you got to that slide, but are there places like UPS or school bus fleets or businesses that have adopted sort of a fleet of vehicles utilizing electric technology in Montana?
Sorry, the last part of the question kind of cut out. Yeah.
Yeah, are there businesses or fleets in Montana that have adopted electric vehicles, like a UPS unit or a school district or you know, some other company like that have switched a whole batch of vehicles over?
No, not at this time. On the sort of UPS delivery truck side, there are electric options available. I think a lot of those decisions are made, you know, at their corporate level. I know in some states that have larger fleets of those, they are transitioning those. I believe UPS in New York State is moving to all electric. Yeah, not yet in Montana. On the school bus for school district side, there is a lot of interest, and in fact, our most recent funding opportunity that we put out with using the Volkswagen funding, there was significant interest in electric school bus options and replacements for the diesel, and the school buses. A lot of them have at least a 100-mile range, can be charged in the middle of the day, so it can work out really well for school districts. So I think we'll see that sooner than maybe even some of the other applications for some school districts where it makes sense in Montana.
All right, next one for you. Do consumers pay for the use of these fast charging stations? Do they just put their credit card in like a gas pump, or do those work differently?
Yeah, it does vary. The ones that we helped fund, we required them to have sort of two payment options at least. So either digital payment option or option through an app or, a phone number to call. Some of them do have card swipers, just like a gasoline fuel tank. So in sort of how you can pay, that's fairly similar. In terms of the cost, some stations are offered for free to users. I know Tesla early on used to be offered for free. Their supercharging network charging was offered for free to Tesla owners, but that since has changed, is my understanding. And if they do charge, a lot of it is by the time that you're parked or, a certain cost per hour. Some businesses where there's the level 2 stations that I mentioned, they do offer it for free because they're getting the benefit of you being a patron at their business. So it really does vary. I think the most common I have seen is by time. It's a little bit challenging because the law doesn't currently allow those entities who are not utilities to charge based on the cost of electricity. And so they have to figure out a different way to charge the users. But I think it does vary. I think for the DC fast charging stations, that's where you're less likely to see that be free just because of to cover the cost of the station. And how they do it is, it really does vary. It's hard to say there's just one way. So.
All right, one more for you, and then I'll bring the rest of the panel back in. Do we know anything about how often those public charging stations are used once they're built?
No, we don't have, so for the stations in Montana that are currently installed and operating, and have been operating for a while, so there's Tesla and then the Electrify America, which they're kind of a subsidiary of Volkswagen. Now those can be used by any vehicle, but the usage data, we don't have access to those kind of proprietary networks. That information, it's something where the utilities might have a better sense of how much those are being used. Business owners for the level 2 stations would know how much those are being used. Like I said, about 80% of charging happens at home. And so a lot of the usage on the fast charging stations, at least that you'll see, as people traveling longer distances or people coming from out of state. And so, yeah, I don't have insight into exact numbers on that. That's an interesting question to see kind of the how much that is increasing though.
All right, thanks. I know there's a Tesla charging station near Lowe's in Bozeman, and I was making lots of runs because I apparently don't make good lists when I go to the hardware store, and was noticing that it was full most of the summer, just driving by that particular one. Nick, let me come back to you if you're ready for a question there. This one came in a little bit earlier. And this, I think, is about your personal experience driving your electric vehicle. Have you went on any long trips, such as to Salt Lake? Have you been able to find charging stations, and how long did you have to stop to recharge?
That's a good question. I very seldom have used the DC fast charging or made long trips. What I have used the charger at Rocker, and because I travel to Deer Lodge for some activities, I've one time worked in Denver, and so I was trying to figure out how I would get to Denver, and I would have to go to Rocker and then down to south along Dillon into Rexburg and so on. So it can be done, but I have not had the opportunity to do a long trip. And it's also something that I would probably do by myself, simply because I think my wife Betty would probably not want to take the time that you have to plan in to make that convenient. That's why I mentioned that long distance was not a convenient thing. But it's time I usually can spend a rocker. I have spent a half hour to an hour to get enough miles to make sure I could get back to Bozeman, and it's worked out satisfactorily.
All right. Thanks, Nick. Larry, if you're still available, the next one will be for you. Has the Department of Transportation within their own vehicle fleet experimented with any electric vehicles?
Good question. We don't have any yet, but I know that is in the works, our motor pool, the statewide motor pool. So there's kind of two segments of our light duty fleet. There's the fleet that we use for our day-to-day department operations, and then there's the day use fleet that is available for all state agencies. The light duty fleet that we use is a little bit more challenging because we are spread into some fairly remote areas at times, and charging would be fairly inconvenient. But I know that there is some discussion of expanding some of our, at least a portion of our statewide motor pool fleet to potentially include some. But again, as the network develops, again, most of the travelers in our state that do state business are traveling to fairly remote areas. So there's a practicality to it that we're still considering, but yes, that is on the radar to make at least part of our fleet converted.
All right, and I'll stay with you, Larry, for one more. If we went to a more registration-based way of collecting taxes for electric vehicles, how would out-of-state electric vehicles be impacted?
Yeah, another great question, and they would not. That's kind of one of the dynamics we got to work through. Is there's no way to capture those costs using a registration-based system.
All right, thanks, Larry. Nick, let me come back to you. The question, and it's kind of a statement. I'm going to make it into a question. I assume you've shared with your friends your experience driving your electric vehicle. Have any of them been swayed to like electric vehicles or dislike electric vehicles after sharing your experiences with them?
Yeah, thanks. That's a good question. I do have one friend that did buy an electric vehicle, but has used it not very much. Most of the people are my friends and colleagues. Still think I'm crazy, but that said, it's just fun to be able to talk with them about it. I would like to go back to the previous question though and point out that on the long distance chargers, I have gone further distances and not used a long distance charger because I carry with me my charging unit and 3 types of plugs, excuse me, that I can plug in. For example, I've had activities at Whitehall and I can go to the fairgrounds and they have RV chargers and I have the right plugging combination, and so I can get my level 2 charge. So I have done longer trips and probably could do a lot longer trips that way, but it of course would take more time. But anyway, yeah, I don't think I'm a very good car salesman. Not many people have purchased electrics on my say-so.
All right, thanks, Nick. Kyla, the next one is for you, and it kind of feeds off of what Nick mentioned a little bit. Does the DEQ have any programs? Are you aware of anything that's working on sort of standardization of charging and plugs between different vehicle manufacturers?
Yeah, that's a good question. We don't have any, we're not developing as an agency charging standards. Just a couple of notes on that. That, for the stations that we fund under the Fast Charger Ride program, we require that there be at least a CCS, so the combo and the CHAdeMO plug for those stations. And then we also, along with the other Western states, have kind of developed these guidance or voluntary minimum standards, which include in addition to at least 50 kilowatts of capacity, other standards looking at, access to amenities and restrooms. So we do in the stations that we're funding try to have some sort of standardization for the, improved user experience. But yeah, I think there are just generally for the industry, there is a move to standardization. And I don't know if Tesla will ever go away from their own standard, proprietary standard, but there's attempts at a move towards that. And even that CHAdeMO, so the Nissan Leaf, the one that they use, they're moving, a lot of charging station companies are moving away from that CHAdeMO. So it's changing, but I think that's an important component of all of this, is to have some standardization, especially for the fast charging stations.
And Kyla, let me stay with you because I think you had a question or a slide that was somewhat related to this topic. So when looking at emissions produced by electric vehicles, are the emissions from the generating power source taken into consideration?
Yeah, and so that slide I showed was showing the emissions base, the well-to-wheel emissions, or well or electricity source to wheel emissions. And so for electric vehicles, it considers the tailpipe emissions, which of course are zero, and then whatever electricity source is powering those vehicles. And for the average for Montana, based on our electricity mix, it's about or it's less than half of the annual emissions.
All right. Well, thank you very much. I think we've gotten through all the questions, so I want to take a moment to thank Kyla, Larry, and Nick for presenting and sharing their expertise with us today. A lot to think about. Also want to remind folks, we did have some questions come in today about utility infrastructure and electrical generation, and I didn't bring those up today because our final session will focus on the electrical grid and kind of we'll have Northwest Energy here and someone from the rural electric cooperatives to talk specifically about that aspect. So skip to that one for today. Kind of March 4th will be our next session, and we'll kind of be talking about some research and some legislative options that are out there. So that'll kind of be the focus of the next one, and we'll have somebody from MSU's Western Transportation Institute, also Oregon Department of Transportation, talking about one of the studies they've actually done and what they learned from it. And then someone from our Montana Legislative Interim Transportation Committee talking about the different proposals that they're thinking about. Before I sign us off here, would any of our presenters like to have any final comments they'd like to share? Maybe I'll start with Nick. Did you have any final things you wanted to share?
No, other than that, I think it's a journey. It's a long-term journey, and I think it's pretty clear that electric propulsion is motors themselves are really very much suited to what kind of transportation and needs. And I think there's a lot of application in the agriculture sector, big tractors and other loads that will eventually increase. So it's a long journey, and I just think in order to do it correctly, we all have to be educated and learning and understanding, and there's a lot there to learn. So appreciate everybody that's on, and thank you very much.
All right, thanks, Nick. Larry, did you have anything you'd like to share?
Yeah, just quickly from just the transportation funding perspective, likewise with Nick, it's a long journey. Electric vehicles are certainly a component of that, but the issue of transportation funding is much broader than just this. In fact, there's a lot of emphasis right now on EVs just because that's the emerging technology, but there's much broader issues with transportation funding that we need to consider going forward. So I appreciate the time and the invitation to participate. Thank you.
Thank you. Kyla, any final comments you'd like to share?
Sure. Well, thanks, Joel and MSU for hosting this. Really happy to be a part of it, first of all. And thanks for everybody who joined to participate and learn more about electric vehicles. I think it's a really exciting time for transportation, for electric vehicles. I mentioned some of the models that are coming out. I mean, just watching the news is very exciting. And it's an exciting technology just in terms of cost savings and some of the environmental benefits, but also just in driver experience, getting in an electric vehicle. I highly encourage those who are interested to do a ride and drive, or if you have the opportunity to do it, because it's incredibly quiet and just exciting to be in an electric vehicle and drive one. So happy to be here, and happy to answer any additional questions and be a resource. Our office is, and thanks again. Really, really happy to be presenting today.
All right. Well, thank you everyone for joining us. We did record today's session. We'll paste it on the website that I put in the chat window, same place you logged into today's webinar from. So please mark March 4th and May 6th on your calendar, and we hope you'll join us for some more topics with the electric vehicles. Have a great day, everyone.
Thanks.